So now two systems, and one will be put into series and one will show you parallel, and we'll see how the volts will behave. So let's go to system 1, from the battery through the fuse box, through the fuse, through the circuit, and now currently we have one light. As we saw previously, through that light it will consume 12.4 volts. So now we're gonna connect this light after in series, just like a television show. One series, you will look one show after the other, not all at the same time. For safety, I will disconnect the circuits, and now I will use the negative from one light and I will connect it to the positive of the other one. So goes this way, and from here the negative to this system. So if I turn on the light now, you see both lights are weaker. So what has happened? We had a 12-volt difference between this point and this point in the first case, and that's still there. So now let's check just after one light, and now we'll see 6.5, if I'm seeing it correctly. So what happens is that the volts are shared in between the lights. This one will use 6.5 and this one will use about 6.5 or a little bit less, and that leads to weaker lights. Series, one after the other. So here we have a second circuit, and where you can see the difference, this is the positive through the switch. From here you see a point where we'll bring for both lights in a parallel connection the volts to each light. That means each light will get 12 volts. And the negative is a common one. Both come together over here, and we'll go back to the switch board, and from the common black to the black of the battery. So if I turn these two on, they should be quite bright. So here you can see it. These ones are parallel. 12 volts the same, because the volts are going equal to each connection. Here the volts are in one series. It will separate, it will divide the volts between each lamps. Series, parallel.